The KC-135 Stratotanker, originally developed in the 1950s, has long been a central pillar of U.S. air operations due to its ability to extend the range and endurance of a wide variety of aircraft. Its original function was straightforward: to refuel other aircraft mid-flight, enabling bombers, fighters, and reconnaissance planes to operate far from home bases. Over decades, this aircraft has become a highly reliable and durable platform, capable of flying long hours at high altitudes with consistent performance. The nature of its missions, often over remote areas or near contested airspace, has made it uniquely suited to serve as a platform for secondary roles. By leveraging its endurance, payload capacity, and operational flexibility, the KC-135 is now being transformed into a highly capable airborne communication hub, fundamentally enhancing U.S. military command, control, and information capabilities. The process involves replacing or repurposing some of the existing refueling infrastructure, specifically the refueling pods, into equipment capable of handling secure, high-speed communication networks. These airborne nodes act as mobile network hubs, bridging information across diverse platforms that would otherwise rely on fixed satellites, ground stations, or line-of-sight communications. In modern operations, where decision-making speed and situational awareness are critical, this ability to maintain near-instantaneous communications over vast distances is transformative. Traditional satellite links, while highly capable, can be limited by latency, bandwidth constraints, or susceptibility to anti-satellite actions. A fleet of airborne communication nodes mitigates these risks by creating a network that is mobile, adaptive, and less vulnerable to singular points of failure. These converted aircraft can perform multiple roles simultaneously, maintaining secure channels for pilot communications, relaying intelligence from reconnaissance and unmanned systems, and distributing operational directives from command centers. Data streams are not limited to voice communications; they include sensor information from aircraft radar systems, targeting data, movement of friendly and adversary forces, and real-time situational assessments. The nodes process and transmit this information in a coordinated way so that all participating units, manned aircraft, unmanned drones, naval vessels, and ground forces, share a synchronized operational picture. In effect, the airborne nodes serve as the connective tissue of the battlefield, ensuring that decision-makers have accurate, timely information, which directly influences the speed and effectiveness of responses to evolving threats. The strategic advantage is amplified by the endurance and reach of the KC-135. Unlike smaller or specialized communication aircraft, which may have limited range, endurance, or payload capacity, the KC-135 can remain on station for hours or even days. This persistent coverage allows for continuous communication in areas where satellite coverage may be degraded or where adversaries may attempt to jam signals. By integrating modular communication systems into the aircraft, upgrades can be applied incrementally, keeping the network current as technology evolves. This adaptability ensures that the airborne communication nodes remain at the cutting edge of secure, high-speed networking without requiring extensive redesigns or entirely new aircraft fleets. The resilience of the network is another critical aspect. Modern military operations recognize that communications are a primary target for disruption. By distributing network capabilities across multiple airborne nodes, the system avoids single points of failure. If one aircraft must leave its station, encounters technical issues, or comes under threat, other nodes maintain the flow of information. This redundancy ensures that operational command and control remain intact even in contested or denied environments. In addition, the mobility of these aircraft allows them to reposition based on operational needs, further enhancing network survivability and flexibility. The network is no longer tied to fixed locations or satellites alone; it becomes a dynamic, adaptable entity capable of responding to changes in real time. The integration of unmanned systems is particularly significant. Drones rely on reliable communication links to maintain control, relay sensor data, and execute coordinated operations. By providing continuous airborne relay coverage, the converted KC-135s allow drones to operate at greater distances, maintain longer loiter times, and execute complex missions without the risk of losing contact with command centers. This capability expands the effective operational envelope of unmanned platforms, making them more versatile and lethal while reducing risk to manned aircraft. Coordinating swarms of unmanned systems, along with manned aircraft, through airborne nodes creates a level of operational cohesion and synchronization that would be impossible with traditional communication infrastructure. The implications extend beyond tactical advantages. This conversion represents a fundamental shift in how the U.S. military approaches information superiority. Rather than relying exclusively on ground-based or orbital systems, the creation of a mobile, high-altitude network allows commanders to maintain control and awareness in contested spaces. Rapid redeployment is possible. The same aircraft can move to a new theater, repositioning communication coverage as threats or operational priorities shift. This mobility ensures operational continuity even in the face of disruptions to conventional infrastructure. The network becomes inherently resilient, redundant, and adaptive, capable of maintaining a persistent advantage in contested scenarios. The benefits are compounded by the dual-role capability of the KC-135. These aircraft continue to perform their original refueling mission while simultaneously acting as network nodes. This efficiency maximizes the utility of existing assets and avoids the logistical challenges of introducing a completely new class of aircraft into the fleet. Operational commanders gain both a fuel resupply capability and a mobile communications network in a single platform, streamlining mission planning and resource allocation. The modularity of the systems also means they can be updated to accommodate new encryption standards, next-generation communications protocols, or integration with emerging technologies, ensuring the platform remains relevant for decades. The overall effect of this transformation is a dramatic increase in the operational tempo and effectiveness of U.S. forces. Faster, more secure communication enables quicker decision cycles, more precise coordination, and better risk management. By unifying disparate assets under a cohesive, airborne network, the U.S. military can execute multi-domain operations with unprecedented efficiency. Airborne nodes reduce the reliance on static infrastructure, mitigate vulnerability to electronic warfare or physical attacks, and enhance the ability of forces to operate across vast distances in highly dynamic environments. The combination of mobility, persistence, and redundancy ensures that even in the most contested scenarios, U.S. forces maintain an informational edge that is decisive in modern conflict. Converting KC-135 refueling pods into airborne communication nodes represents a force multiplier on multiple levels. It leverages existing aircraft and their operational strengths, dramatically increases the flexibility and resilience of the communications network, integrates manned and unmanned systems more effectively, and enhances situational awareness across all domains of operation. The innovation lies not only in the technology itself but in the strategic and operational thinking that maximizes the utility of existing assets to create new capabilities. The U.S. Air Force thereby gains a persistent, adaptable, and highly survivable communications network that reinforces superiority in both conventional and contested environments. This is a clear demonstration of leveraging innovation, endurance, and mobility to maintain operational dominance and decision-making superiority, ensuring that U.S. forces remain agile, connected, and informed in every operational scenario.